What's up, guys? Welcome to the Wolf of Young Street podcast. My name is Victor. I'm your host. Today, my guest is Edward Madojemu. He is an animator who specializes in extended reality and game development. And maybe he can help me today and clarify the difference between augmented reality and virtual reality and mixed reality, because there are so many realities, I don't know what's real anymore. Welcome to the show, Edward. So let's start there. What's the difference between these things?
Yeah, first, thanks for having me. So all of those things, AR, MR, VR, they all fall under one umbrella term, which is extended reality. So that's XR. So you'll see that probably a lot. It's kind of the shorthand for you generally work in one of those fields. So the difference is kind of, I'd say the difference is levels of immersion. That's how I would describe it. So on one end of the spectrum, you have AR. So AR is what you've seen on your phones, right? It's like Snapchat filters. It's like when you're maybe scanning your room to get a measurement or something. That's AR. What it's doing is it's overlaying something on top of reality, right? So that's any sort of digital interface that goes on top of whatever you're seeing in your camera feed. And it's usually limited to phones. That's really where AR tends to live right now. It does not necessarily, but it's where it lives right now. And then if you go further up, you're getting closer to mixed reality. So mixed reality is what you see in like one of these actually. So you see in one of these guys. This is the Quest. Meta Quest 3. So, and it's where you see the Apple Vision Pro. So those are mixed reality devices in that they are POV, but they are integrated. So what that means is you're going to see digital interfaces and things that overlay on top of the real world, just like AR. But the difference is they tend to be more directly integrated. They're more spatially aware. There's more contextual computing happening there with the space. So
yeah,
mixed reality is kind of it's like an evolution of AR. I would say it's like the next phase of AR. I wouldn't say on the fundamental level they're not all that different, but it's kind of like mixed reality is just the more human centric version of AR, I would say. And then feel free to stop at any time, by the way. And then you get to the furthest end of the spectrum, which is VR. So VR is, again, this device does both actually, MR and VR. But
yeah,
VR is you're fully in a virtual world. Everything you're seeing is virtual from that point on. And then it's kind of scaled one-to-one. So in a way where you're not just looking at a flat image that's engulfing you. There's actual depth. There's actual, like, if you move your head, things are going to move in parallax the exact same way. You can walk around virtual objects. So it's kind of like, it's almost like a degree of, across the spectrum from AR all the way to VR, it's kind of like how immersed are you? How much of what you're seeing is real versus how much of what you're seeing is virtual. So VR is at one end of the spectrum and AR is on the other end. So it's kind of, that's the best way to think about it.
So where is I'm actually curious, what's the state of the art in all these XR type tech at the moment? What would blow my mind if I was in the industry, what would blow my mind right now that we can do right now with this tech?
That you can do. There's honestly a lot of things, but I find, so a lot of what you'll see, what's talked about, like, the metaverse and all that, you'll see the VR side of things. You see like, oh, it's really cool. You can be in all these virtual worlds. You can, play Star Wars. You can play Batman. You can be Batman. You can do whatever. And that's really cool. Don't get me wrong. The entertainment side of VR is, the potential is incredible, but we've kind of known that for a very long time. What at least personally excites me about these tools is weirdly the productivity side of things. So like a lot of what I do in VR is 3D modeling. Right. So sometimes, let's say this happened earlier this year, actually, we had a client who was mapping out a location for a stage play. Right. And they're trying to scout how the scene is going to look based on that play. And she had a script written down. She had an idea of what the layout was going to be, but they hadn't tested it. They didn't know what it is, but they did have the rough dimensions of what the space looked like. So what we were able to do is we did a joint session. It was myself, the client, and the producer. And what we did is all three of us were wearing mixed reality headsets, and I was able to sketch out the room, the dimensions of the room, and place actors at life size, like just mock-ups of actors just in life size, position all the elements where the TV is going to be, where the desks are going to be, and we're able to map out the entire scene in about an hour's time, just looking through it. And it was to the point where, like, there was a point where we had to tell the client, hey, don't sit down because they're not real chairs. Like, we had to basically constantly remind her, like, don't sit down because you'll fall. It's like there's nothing there. But when you can compute in space in that way, it means that it puts you in a position where you can solve a lot of problems that you wouldn't be able to solve until you have the real thing in front of you. So there's a lot of additional planning you can do. There's a lot of like coordination you can do. It's like trying to do a Google Meet type thing, but instead of looking at yourselves on flat screens, you're all in a co-located shared space, and you're not bound by physics. So you can scale things up, scale things down. That productivity, we've used it to, like at Runtime Data, which is where I work, like we use it to do a lot of pre-visualization, whether it's like a venue of something, whether it's an event that's about to happen on installation, we will do virtual mock-ups of it in mixed reality. So you can see the real world and you can see how the thing you are trying to build fits into the real world. And that's, to me, that's just the most magical thing that you can do with like XR right now. It's just the ability to bring things that don't exist yet and have them be fully functional, interactive before you've actually built them. It's just, to me, that's like the most amazing capability right now.
Yeah, no, it's incredible because in my mind, I've seen these things, like people are using it for like in real estate. You know how, you go to a certain house, you want to explore what the house looks like and that kind of thing. People are using it in that way to kind of like give you a virtual tour of a place that you're looking at right now, a property. Estate, yeah. And there's also obviously in applications in the medical field where you can do a mock-up surgery of sorts, right? Which is kind of wild to me.
So there's a company actually locally in Vancouver, BC, that does that. They're called Precision OS. So they actually do medical training entirely in VR.
Yeah.
So it's incredible.
So I wanted to know what kind of tools go into that kind of pre-visualization. How do you create these worlds, say, and for the application, for example, that you were trying to say in terms of the movie application and that kind of stuff? How does that work out? What kind of tools are you using? Feel free to go into kind of sort of the tech in the background that we don't see as people who are not immersed.
Absolutely. Okay, so today we're working with, there's somewhere around 4 or so tools we end up working with at Runtime. So what we do is, obviously there's this guy, this is kind of where I do most of my VR XR work with. But in terms of software, there's an app on the Quest store called Gravity Sketch. So Gravity Sketch is probably, in my opinion, the best 3D productivity tool that's available in VR right now. It's used for a lot of design, it's industrial design. It's used for, in some cases, it's just used for entertainment. Sometimes it's used for you can actually use it to create production ready models as well. So whenever we're trying to do sessions, especially our consulting sessions, we'll kind of bring in our clients and say, okay, we'll bring in headsets and we'll map it out, because it's the difference between spending 2 weeks drawing something and sending to the client and going, actually, I want it like this. Instead of doing that for over a couple of weeks, we have one session with them live. We map everything out, and then they can be very picky and be like, oh, I actually want it this big. And we can scale it up right in front of them and make all the edits. So it's a very great collaborative tool in that way, but also for focused 3D modeling work or 3D mapping work, it's very good for that. So that's a lot of times when we're doing the early stages of what are you actually trying to build. That's what we'll do. We'll do that kind of mock-up and consulting session with you. And then what happens is, once we get to that point, if there's a real life reference, for example, let's say it's a physical room, like it's a real venue you have, we'll use something called Polycam. It's a photogrammetry app, and we'll go in and we'll scan the room. So we'll get it'll give us the dimensions of the room, the rough dimension of the room. Will give us what the lighting and all the space, everything just looks like, feels like. So it gives us a real world reference to use, on top of the actual virtual thing we've built. So it allows us to contextualize both. So we have this thing that we want to build, and we have the real thing, and how do we integrate both of them? So it gives us those two pieces with Gravity Sketch and Polycam, and then the next stage. That's why I got into Unity. So Unity is the 3D game engine. And it's funny to call it a game engine, because I find more so than something like Unreal Engine, it has more applications outside of entertainment, I find, in my experience. I use Unity now more for less entertainment related things than I use it for actual games and direct experiences.
Oh, interesting.
So it's at that point. I think that the VR tool sets, the VR suite and the plugins and the support for VR is just very good. It's probably, I think it's the most accessible version that you have right now. So we're able to take those things, and a lot of times it's going to depend on obviously the output. If it's something that needs to be experienced from a one-to-one perspective, we're going to use VR. If it's not, then we just make desktop 2D kind of things for people to interact with. But when we do use VR, we'll take those two things, the scan of the room, we'll take the mock-up of what we're trying to do virtually. And sometimes we'll either go in and build hi-fi mock-ups of it. And then in Unity, then we're going to add interactivity. So there's a thing we did with the printer a few months ago where we wanted to basically just test out what the printer looks and feels like. It was mostly about testing the UX for the interface. but just also the ergonomics of does the design actually work together holistically, right? So in that case, we took this printer model, we added the functionality so you can actually hold the paper, you can actually put the paper in, you can scan things, and then it updates on the interface. So we also recreated the interface, and you can. The best part about it is with VR, you can actually use your hands, like your actual hands, to interact with virtual objects. So our testers can kind of go in and use the interface like it was in front of them in context in the room they're standing in, and try it out.
Wow.
So just from that process of doing that, we can kind of simulate what it's like to use the finished product well before you've actually manufactured anything. So Unity is where you put all that interactivity, but there's the last bit of that equation plus Unity is there's a tool called Rive. So Rive it's kind of like a web-based, how do I put it? It's a tool for creating web-based or interactive graphics. So it's like primarily I find it's used for UI and things like that. But what we use it for is we're able to recreate any sort of data-oriented graphics. So if I wanted to show you, we did this with the project we did with Rivian just recently, where we had like an actual functional GPS in this virtual project, because it would basically sample wherever the virtual car you're in is located relative to the world map. And it will update your position based on that. And with Rive, you can kind of create graphics that respond to data and information and inputs. So we mix all those three things together to make, like, not just allow you, because a lot of previous stops at, like, you can see it. Like, a lot of previous is just showing you what it looks like. And I find that's very good for a lot of things like architecture, if you just want to see it. But when you want to actually be able to operate something, when you're trying to test for UX and how humans will interact with something, or how it might actually play out, or if you're doing training, you want interactivity, you want feedback. So a lot of what we try to do is blend all those things together, where you have real world context, real world scale, one-to-one visualization, but also interactivity. So then you can play with stuff. You can actually move it around. You can get a feel for if your design is working. You can get a feel for if your product is working. It's fun to use, what other opportunities might arise. So it's kind of that's kind of like the four main things we kind of sandwich together. And it's interesting because, like, my role is closer to technical artists these days, because there's a lot of different disciplines you're bringing in. You're bringing in a bit of 3D modeling. You're bringing in a bit of programming. You're building in some, like the UI and design. So there's all these aspects of things that come together into this weird overlap of, like, if it needs to exist and if it needs to be interactive, we have to, like, I'm kind of, my job is to kind of pull all the pieces together. So,
yeah. No, I'm actually, wow, that is a lot. You were not joking when you said when you said there's quite a bit in there. I wasn't expecting that much. But, what you were saying there got me curious. So I'm trying to recreate a room. How much of that is computer, like, you scan a bunch of dimensions into a computer program, and it's like, how much of that is automated? You probably did some intro tech or something like that, where you would, like, grab a dimension and reproduce it within on the paper or something like that. So how much of this idea of reproducing a room or whatever is automated?
Quite a bit, I'll say. A lot of it is automated. Like, if with specifically Polycam, what we've been using, Polycam is very, very, like, it does a lot of magic hand wavy stuff for you, in the sense that you go into a room, you take photos at different angles, you move your thing around. If you have a LiDAR scanner, it's even better. But it will do a lot of the figuring out what the space is. The problem is there's always going to be a limit to how much data you can deliver and how much you can process. So you'll get a pretty solid scan. Like, it will look, the space and dimensions will roughly be correct. The images will look really pretty. They'll be assembled in a way that it looks like a 3D model. There's going to be some loss in resolution depending on how big you're scanning, but a lot of it will assemble the 3D model for you. But the tricky part is there's always, and the same, you find this in, like, similar fields like motion capture. If you're getting any real world data and you're trying to translate it to a file format that's easy for a computer to read or edit, you will always need a substantial amount of cleanup. So you need somebody who knows how to operate in 3D spaces, whether it's for motion or for 3D geometry, to ensure that piece of geometry you're getting is clean and accurate. Because, for example, if you had, let's say I was scanning we scanned a building very recently, like a building that's ongoing construction for a project.
Yeah.
And the gaps between because the walls haven't been filled in yet. So the gaps between there cause issues, because relative to Polycam, it knows there's a wall here, but because that wall hasn't been filled in, the gaps are the detail is too fine for it to get extremely precise separation of the walls on the different gaps between them. So you need an artist to go in and then make sure those things are clean. So a lot of it is, like, you get the big upfront chunk of it being optimized, but to make the data actually usable, that's where it gets tricky. Because another thing is 3D scans can be quite heavy, like in terms of like the polygon counts that you get, there's
Yeah.
easily millions of triangles, and devices are very good these days. But even then, especially because a lot of times our targets are accessible things, like we're trying to build things for the web, we're trying to build things for VR, that mobile devices or devices that aren't too heavy duty. Like if your client needs a gaming PC to run your thing, it's not going to work. So we have to figure out how to then optimize those kind of heavy duty models and make sure they actually run on these things in an efficient way, because the moment it stops being convenient, it's like I find people tend to tap out. So it's like we need to make sure that's the hardest part. That's the part that you can't automate. It's like making sure that this thing not only looks the way you need it to, but it actually runs on the devices without, overclocking them or, pushing them to the brink. So there's a whole aspect of that needs to be, that then requires a human hand.
Yeah. Yeah, we'll talk about that, the integration aspect a bit later, actually. The other part of what you described earlier I was curious about is I don't know if this AR, VR, XR in general technology applies to push towards like automated vehicles, so vehicles that will drive themselves. How much of like this XR experience comes into that?
That's a great question. I'm not like, it's hard to say at this point. Because like in cities like Silicon Valley, right, they're already operating self-driven cars and whatnot. So it's a field that's still kind of cementing itself. But I find the VR side, because anything with any XR in general tends to be human centric, right? So it's not. So I see like things like displays overlaying like virtual displays on top of the real world is a huge bonus. Like if you look at the HMI kind of interfaces in like cars like the Rivian cars and the Tesla cars, they already have this way of trying to give the user more information in a more user-friendly way. So I can see like almost like MR practices being integrated into that down the line. Like let's say you're sitting inside a self-driven car and like the displays, like the actual windshield is now a display and it's overlaying information on top of what you're seeing. So I can see that integrating, but right now the devices themselves, all the XR devices tend to be about the human experience. So it's less likely to, unless people are sitting in cars wearing VR headsets, which funny enough, we did that at our event with Rivian, like,
no.
Yeah, I think about a week ago. So that's what we asked what the experience was. We overlaid a virtual car experience while you're sitting inside the car. We mapped it 1-to-1. But so we've already experimented with that. But outside of entertainment, I can't really see a use case for having people wear actual XR devices. Whereas if you turned maybe the screens or the windows of the car into kind of like those overlays, so you could add contextual information of like, let's say I'm looking through the windshield, it can judge the distance between me and something, or it can, it's indicating additional information or GPS information as I'm looking over the screen. I can see that being a possibility. It's probably going to be a luxury, because at the end of the day, it's much easier to have standard displays in the car instead of like having them be overlaid on top of the world. That's just computing wise and financially getting the glass. It's so many holographic displays are just a lot. But a different problem from that. It's a different problem. But from that perspective, I can definitely see that happening at some point in the future.
Yeah, but but also I don't know if you saw what's Facebook Meta released these glasses that are capable of like kind of like video game behavior. Basically, it's very similar to like maybe you're in a GTA 6 game, or not GTA 6. We haven't gotten that yet.
Soon.
Yeah, but those glasses, I find they're so cool. Just being able to kind of like move through the world, just you have the glasses on, you're able to kind of almost like having a camera on your face, a computer on your face, basically. That's incredible, though. Yeah. I don't know.
When I first got into the VR industry, there was kind of like everybody was just waiting for it to become mainstream. Everybody's waiting for like, oh yes, everybody's going to be wearing a headset left and right. That never really happened. COVID was the opportunity, and it didn't take. So it's like I think these devices are kind of being framed more as like they're closer to laptops now. That's how before it used to be they're trying to replace the smartphone with these guys, but now they're being framed as laptops. And I kind of agree, because these headsets have very specific use cases. They're things that are incredible at. Like I'm at the point where I have a hard time 3D modeling like in Blender on my laptop because it's much faster to do it in a headset. You don't have to rotate the camera 40 times to make sure that the 3D model looks right. You can just grab the polygons and move them
And
into
turn
lines
it,
in
right?
VR. So it's so much faster. There's things where it's very intuitive for, and there's things that it's very slow at. Like if you're trying to watch something as simple as watching a video in a VR headset, unless you're using something like the Apple Vision Pro, it's very clunky because you have to aim and point and hold the actual playhead and drag it where you need to be. So it's like for a lot of those basic computing things, it's a lot slower. Whereas if you look at the Ray-Bans, the Meta Ray-Bans, they've gotten popular very fast. Like I'm surprised at how quickly and how commonly people are wearing them and using them in everyday life and, recording. And I feel like that's,
Wow.
in terms of replacing smartphones, that's where that's going. Like the old Project Orion, which is the one you saw, the holographic kind of, that one is, again, I don't know how the tech works, but it looks like they're easily probably like 5 to 10 years away from it actually being cost effective. But it's like, I feel like that is the goal for everybody in terms of getting XR to the mainstream. It's like getting people using those things on a daily basis means there is a lot more access to, like, it's just the way we interface with things. It changes up the dynamics a lot because you're always partially in the real world. Because I think that's the thing. People, the most successful parts of, I think, XR, especially when it's not for entertainment purposes, tend to be when it situates you back in the real world in the context of where you are. Because you don't have to worry about your safety of like, oh, I'm wearing this thing, I don't know who's around. Because that happened a lot in the early days where you're working in a VR headset, but you have no idea what's going on outside. So it's a little, unless you're in a very safe space, it's not. Whereas with mixed reality, you can see the room, you can see everything. You're just adding more things on top. You can extend your screen displays. So that aspect is, I think that's where it's going, and I'm hopeful it goes there because it's going to open up. I think we're not even fully aware of what people are going to do. We're not sure what people are going to do with it yet. So the more it gets, we're going to find all these new behaviors. We're going to find these new opportunities. Like the way Snapchat filters and stuff just took over for a while. It's like, we're going to have one of those moments where it's like people are doing things we never expected with it. And we're all going to try and figure out how to like support that. So I think that's going to be exciting. And it looks like, in fact, both Meta and Snapchat, I think, are both pushing for that kind of wearable, like really thin glasses, really comfortable thin glasses that you can wear and have these like overlays. It tells me that there's, at the very least, there's a lot of excitement for it. And so like they're willing to push, and it means that all the developers, myself included, are just ready to kind of, whenever that becomes, there's enough infrastructure there, a lot of us are just ready to jump on it and see where it goes next. Sorry.
Yeah. No, I actually want you to kind of place us and maybe kind of crystallize this idea for us. What is the role of AI in the development of all of these things?
That's a good and loaded question because there's some people who are probably listening and like AI. So it's very, there's people I've in the circles I work in, I find people are very polarized on AI right now. They're very I either love AI, it's the best thing since sliced bread, or it's like I hate AI. Yeah, it's one of those two extremes, and it's very interesting. I'm in the camp of like it's a tool. Like I think of it as like, I don't know if you're familiar with procedural generation in video games, but it's kind of like if you've seen like Minecraft, for example, you're familiar with Minecraft, right?
Okay.
So the way Minecraft is built is you don't have a developer manually building out all those blocks and placing them in the world. They have kind of algorithms to generate the terrain. So there's slopes and there's math used to determine how high they are and how low they get. At what point does sand spawn, does water spawn. So it's all kind of algorithmic generation of worlds. And the thing about procedural generation is you'd think the magic promise of it is like, oh, I can press a button and very quickly make varied worlds and stuff like that. But at the end of the day, it is an algorithm. You have to kind of teach it to operate logically. There's a set of rules you're using. And then once you've built it, it can do as much as you've taught it how to do. So I find like AI, especially things like image generation and language learning models, it's basically that on steroids. They've found a way to train it to like a very wide range of things it can do and it can operate very contextually. Other than that, it's still not like it. I think it has a potential to speed up processes. Like a lot of game developers will use procedural tools to build levels. So instead of an artist manually placing every brick or every street or every lamppost there, they have like, maybe there's a curve they'll draw, and based on that curve, the system knows how to place a bunch of lampposts along that curve or a road, or it knows that when the curve turns like 90 degrees, it knows that it's going to use a different type of asset to make sure the slope feels organic. It's things like that. So there's an opportunity for it to speed up the way things are developed. I know developers who are talking with ChatGPT to figure out how to do things, how to program things and do them faster. I know artists who are
There's talk
training.
now.
Yeah, exactly.
There's talk now that programmers don't actually know how to program anymore because ChatGPT does it all. Have you heard that?
Yeah, exactly. I've heard that. I've heard, it's funny. I've heard both extremes of like programmers being like, sometimes like I've heard both extremes of like it's bad, it can't give you anything usable, but also them being like this saved me so much time. Like it almost like gives me a second, like an assistant to help me do the things I don't necessarily need to be doing. And I've seen that across the board, and I feel like to me that's where I want to see it go. Like there's like again, I think a lot of people we're still caught up on the ethics and all that. Absolutely, we should be doing ethically, but I also feel like if we're going to I feel like there's a certain point we can't keep fighting for it to go back in the box. It's not going to go back in the box. So I feel like, especially from the artist, because I have a lot of artist friends who are just very anti-AI, and I'm like, I get it. Like it sucks to have your work and your value kind of almost like artificially extracted from you. But I feel like if you're going to fight for anything in relation to AI, you shouldn't be fighting to just undo it, because you can't undo it. There's too many people with a vested interest in keeping it alive. I feel like fight for the compensation, like the rights. Because if you're able to, okay, they've trained them, they're using your art commercially, find a way to make sure that you see that money. You see a royalty or something every time somebody uses something that's based on your work. There's ways for that to happen where like you can actually benefit from this, instead of, because I find a lot of it just ends at, oh, we're not going to talk about AI at all. I'm like, talk about it, fight for that opportunity, because there's even like there's people I've talked to who are like open to the idea of exactly like that kind of thing of like being able to just like I talked to a lot of illustrators, and some people I've talked to very few people. Most people are just angry about this, but like very few of them are kind of like who are like, oh, I would love if I could just be free to paint and be able to train that and license that out. So it's like, okay, a company wants to use my art to something, they can, I probably get in trouble for just even suggesting this might be a thing, because I've talked to people about this, but like being able to license out that work and make money just for being an artist and having honed that style. There's ways for that to happen, but the problem is, I think you have a lot of bad actors who kind of built these models unethically. They just scraped internet, and they didn't value the people they took this from. And then you have people on the other side who are rightfully angry, but I think almost so angry that they're not willing to they're fighting for just undoing all of it.
Okay, so in terms of game development, I grew up on like Disney movies where a lot of the characters are kind of like, I guess they were hand drawn, but feel free to correct me on that. But they like, you conceptualize, how the character looks. Maybe they have a big head, or maybe I don't know. Think of any Disney character and any of those characters, right? Animaniacs and those kinds of comics, right? So how is that done now? Like, how do you? I want to know kind of like with the workflow from coming up with a character, animating the character, and integrating that into a world. I want to know about that aspect of, well, it's basically the entire game development process.
Okay. So from game development standpoint, I'll say it's similar to what you have in like the film world, but up until a point. Because again, you are making a product, so things need to function more than they need to just look pretty. So with games, it's like you'll start the same place as there's a concept artist, director or somebody has come up with this character. They have an idea of what their backstory. Concept artists will work with the team. There's a lot of back and forth of like, okay, we'll do a sketch here, we'll do an expression sheet here. And then when they finally figure out what they want, how they look, how they feel, the colors, the textures, the references, they put that all together as a package. They're done. And there's like, a lot of times they end up with like a turnaround. So it's like, they'll draw what the character looks like on a normalized uniform kind of like arrangement. So you can see what they look like from different perspectives. And they pass that on. In most projects now, it's 3D. Right? 2D still exists, but not as common as 3D. So in most cases, it's 3D. So 3D pipeline they'll pass that to a 3D modeler. The modeler spends however long modeling that character as much as faithfully as they can. There's often so many revisions just to make sure things are perfect. And there's all these things, technical things you have to worry about as well. Sometimes in games, a big thing is poly count. Because when you're humans, like any sort of living creature, they're generally harder to do, because like it's in games, it's generally easy to render like static models as long as they're not too heavy. It's pretty easy, and most computers can handle it. But when you have something that needs to bend and contort and move, especially in a naturalistic faction, and it has to squash and stretch. That's where it gets complicated. That's where it gets a little tricky. So there's a whole process that's done to make sure that not only does there's a step called rigging that basically effectively giving your character a model skeleton, right? And making sure it bends, moves naturalistically. But then there's still things you have to do optimization wise, where there's things like textures where you have to make sure that if maybe the character has a glowing staff or something, that has to be dynamic. You have to make specific textures that can allow for that. You have to make different things to kind of get the different effects like fur or hair. There's there's additional bones you're adding to the skeleton to make sure the hair can bounce properly. There's things like that, right? So, and then once you've done all of that and you've prepped the character technically, there's this step of like optimizing, which is like, there's something they do called, they're called LODs, which is level of detail. So a character in most games, most like characters, you're not actually seeing one character. You're often seeing like anywhere from like 4 to 6 versions of the character. So depending on the size of the character on the screen, it will dynamically blend between a high detail one to a very low detail one. So it means that at any given point, because the way games generally work is everything you're seeing is being rendered. Oh, that's an interesting effect. Everything that you're seeing is being drawn. Yeah, I saw it like 1 second to it. Everything you're seeing on screen is being drawn like every frame. So like what that means is every frame, it needs to make sure that what it's seeing, what's on screen is as optimized as possible. So it can make sure it draws at a steady rate. If it's too heavy, and it starts slowing down the process, that's why the frame rate starts to dip. So by doing this process, you're basically making sure that the computer is only rendering a level of quality that it needs at a given point in time. So depending on how close your camera is to the character, is going to pick the hi-fi model. It's right up. If it's a cutscene, it's going to pick the highest fidelity one. Whereas if your camera is really pulled far back, then it's going to go, okay, I'm going to use the low version, because you're not going to notice that this is a high version, because it's much smaller on screen and the details don't need to be there. So that's a big step of the optimization process for it. And then I guess the final aspect of it that needs to be factored in is the actual controlling aspect of it. Like even if it's a character you don't control, there has to be some sort of logic for how they operate the animation behavior. So that's like, there's something called a state machine that's basically used to determine the character's behavior and how they move and how they do and how they react. So the state machine will basically just have all the possible states of what the character could do. They could be running, they could be standing, they could be idle, they could be sitting, every one of those things. When they're talking, there's different state, roughly. This is kind of a simplified version of it, but there's a state for each one of those things. And what's the machine part of it is it controls how inputs determine how that changes. So some games will do a thing where if a character's movement, transformation, like they're transformed, their position updates, depending on how much difference it is between the current position and the last position, it'll move them to a walking state or something. And that's if they're moving like on the X and Z axis. Whereas if they're moving up, then it makes sure they're jumping, And then when they've jumped, as they're landing, it switches them to like a falling position. As they hit the ground, switches them to like the animation for hitting the ground and resettling back to the idle, right? So there's all these different inputs you're passing through, where it's like, depending on what's going on in the game, it's going to update the character's movements and animations to look to operate accordingly. So it's kind of it's basically it's funny. It's like, we call it like, it's almost like NPC AI and whatnot in games. It's kind of how it works, but AI in the different sense of what we commonly know as AI is just more of, again, you're giving it a logic and a reason to operate behind. And that's how it determines what the characters should and should do. So generally that process it's a very like product heavy thing. It's like, it's all a pipeline. It's like you're passing in, this is like 6 to 8, like 10 different jobs to get this done. Like these are so many different groups of people are just passing along this character and going through. And as games are hard in the sense of like things evolve constantly based on testing, feedback, ideas change, budgets change. So like these characters are often worked on like literally right up until the game ships, because they're changing things, they're adding new behaviors, adding new mechanics, they're adding new features, they're removing mechanics. Because it's both, you're both making something that has to look good, be artistic, be entertainment, but also has to run and function. So it's like, it's a million pieces, but make something as simple as like a character is probably harder to do than like, you see like a complicated visual effect, like just a building explodes or something. In a lot of cases, that's easier to do than making a character. That's a lot easier to do. So it's like,
yeah. I used to play a lot of FIFA, and I'm just imagining what you're saying right now. So it's like, okay, so yeah, obviously the way FIFA works is for the most part, you're controlling one character for the most part. You're allowed to switch between characters. I don't know if you played FIFA before.
Okay.
So Well, I'm just okay. Just explaining for people at home though. Like the way FIFA works, you're most of the time you're controlling one character, and then you're able to switch between characters, and so the other character that you've just grabbed becomes well your new player one, right?
Different.
And the
Yeah.
others operate somehow. The others have to know as well, which is the level of detail as you're kind of describing it now. I'm realizing well somehow the other characters around this main character, this player one that you're controlling, have to know now exactly how they're supposed to move, right? I know sometimes these things fail. That's how we get all these meme videos with players running in, in weird directions. But for the most part, you know, you guys tell them what to do. But sounds to me the way you've described it for even one character, there's always so much animation to that one character. You have to design, you know, the way the person receives the ball, the way the person kind of like from different angles, how they move and that kind of thing. And it's crazy as well that it's not just, especially in FIFA, it's not just about defining the features of the character, because a lot of these characters are supposed to match like real life people, right? They're supposed to match their real life attributes. Yeah. So I just wonder, like, if you were on a team for like a game like FIFA, like what are the biggest complications that people don't realize going to a game like FIFA?
Yeah, so funny, I actually do know a couple of people who work on FIFA, at least the latest one, like FC or whatever it's called now. But so the biggest thing is because of that pipeline, this is a huge project. There's hundreds, if not thousands of people working on these games. There's so many steps and so many little things you need to pass along. So the process of passing information and making sure things are consistent between departments is a whole thing, because everybody has their own systems. Because at the end of the day, because of the way games and stuff they just work, each department is specialized in one way. So there's the game logic is separate from the animations, which is separate from the way the characters look, which is separate from the different unique dribbling things that they can do versus the grass. So they're all separate things that need to all speak to each other. And the problem is, even if you're a genius and you know what you're doing, there's always going to be things you can't account for, right? So like somebody might do something where let's say I was I'm the character person. I'm doing the base character, and I've built, which is the way I imagine they do it in FIFA. It's like maybe let's say I made the character model in a way where there's infinite little sliders I can adjust to make the faces look different. I can adjust how far the eyes are apart, the eye color, all those things. So I built that system. And then I realized, I actually forgot to account for the height of the players. Like maybe when I built all of that, I forgot to build a system for that. Let's say that happened. And I want to now add that.
Yeah.
What that means is the moment I do that update and I add the heights to everything, not only does the people doing the animation, that's going to break everything they've done, because they've animated this character at this height, which changes how all of the animations look when they do that. So when the person maybe picks up the ball, maybe it's the goalkeeper, they picks up the ball, because the height has been updated, it means that when the person reaches that, they're not touching the ball anymore. So it looks wrong, right? So that's a very simple example of the kind of thing that just goes wrong. And then that's one thing. You also the other thing you have to factor is the ball is a separate entity. It's a thing that exists by itself, agnostic of the other players.
Supposed to fly a certain way and all of those things.
Exactly. Right? So the ball needs to have its own logic. Not only does the ball have its own logic, it has to also be able to operate as part of the player when the player is running with the ball. When the ball gets kicked, it needs to be passed to another player. So it needs to be potentially going to another player. But in between that, the ball can be intercepted. So there's all this logic that has to be. And the worst part is there's a million little pieces of information that you're passing along to make sure the game runs. But the process of passing that information is also expensive, because it's an additional thing that the computer has to do. So you have to manage all that information that's flying around to make sure everything works. You have to manage multiple players playing with each other at the same time. And with FIFA, when I grew up, you could play like 4 people at the time. Play one match of 4 people. So it's like, that's 4 different inputs going on. That's 4 different sets of characters being controlled. That's, what if I decide to switch to a character at the same time as my friend switches to another character on the same team? Who determines who gets there's all these tiny little infinite things, and that's even separate from the art. It's possible, like if let's say an artist accidentally puts like a 4K texture in the map and forgot to de-res it, then there's a huge chunk of your GPU that's just being absorbed. And you're like, why is this game slowing down? Because there's so many things to check. You have to check all of them before you realize, it's this guy.
Wow.
This is what's causing it. So and again, if you had 7 people, it would be complicated. When you have hundreds, it's such a logistical nightmare that basically a lot of times that's why a lot of industry pipelines are very rigid and very strict because of this kind of thing, because otherwise it's nigh impossible to track any of the stuff and how it goes wrong. So the changes. So it's like, because again, you're making a change. You don't know, like at any given point, you don't actually know what the current version of the game looks like because everybody's making changes and they're just being merged at some point. So you push something
Right.
and then you come back and the level is complete. That happened a lot of time on projects I'm working on right now, where like you make a change, update it, and then you come back and the entire thing looks different because somebody made an update somewhere else, and you're like, oh, I didn't know it looked like this now. I have to update this now. It's like
Right.
it's this constant thing up until you actually finish the game, and then you're like, okay, now it's done, but it's not done because there's infinite new things that will happen when you get it to players. Once you ship it out,
Yeah.
and then there's 50,000 people playing at the same time, you're like, oh, we didn't account for that. It never. So game development is incredibly difficult. It's one of those things that like a lot of like. And I used to say when I was a kid until I started doing it, and I'm like, they're like, oh, when they just do this, when they just add multiplayer, you don't just add multiplayer. It's not. You're shipping a product. It's not like I think everyone forgets that. I think it's like because I worked in film, I worked in games, I've worked closer in tech now. It's like I'll say out of all of those things, I find film is a little bit easier because at the end of the day, it just has to look good and make sense. That's generally where if they had to whittle it down to something, it has to look good, be entertaining, be compelling. That's a lot of that comes down to telling a good story. That just comes down to compositions, color grading. There's a lot of things you can measure. You know, it's easy to go back and just be like, oh, this one shot looks bad. I'm going to reshoot it and manually edit the shot so it looks like it fits back in continuity or something. You can't do that with games.
Right.
If this one segment doesn't work, it's a system. It all just falls apart. You need to fix the system. So it's much harder. It's.
So I wanna go to a different aspect of what you do, which is concert experiences and that kind of thing, right? So I don't know how familiar you are with like the technology at Sphere in Las Vegas.
Right.
What makes that experience of concerts and events so special?
So I'll say with the Sphere, it's not actually, I wouldn't say it's particularly new. It's just like probably very big. It's the biggest scale probably anyone's done in recent memory. So I think it's the same appeal of VR or any of those things. It's same appeal with IMAX. It's when the screen or the entertainment is so big that it kind of engulfs. It's easier to immerse yourself into it, right? That's the appeal of that kind of experience, I find.
Yeah.
So like I find the Sphere, because of how big it is, just from both like the outside perspective of I can see this thing. It plays on like I've seen the videos of people looking at it from their windows in their apartments, and it's just glaring into their rooms. Like there's the scale is a big thing. I find scale is a very, very big thing in like the entertainment world. Like if you can get something big enough and shiny enough, it's guaranteed to get attention, right? But when you have something that's 360, like it goes all the way around in this dome. Or I guess not 360. It's like 180, closer to that if you slice it that way. But when you have this dome that's so big, it creates this sense of there's always more because it goes all the way around. You know, it's a thing I find in VR where people in VR will look at places that there's no content because there's something there. Like in the Rivian experience we did, because there's a car behind you, people would always look for the car, look to see if the backseat's there. And when the backseat's there, they're just like, oh, that's so cool. Like it's a backseat. You're expecting to see a backseat. That's why if you're in a car, there should be a backseat. But like, because you know it's a digital experience and there is something behind you, you're like, oh, like I think it's almost like your own expectations, suspension of disbelief. And when something like the dome meets your suspension of disbelief, it feels a lot better. So I find those experiences are like it's a very expensive way to do that, but it does the job in the sense that there's a lot of things you can now do because you've never had this much scale and you've never really had a lot of content tends to be very forward facing. You're looking at a screen in front of you, whereas this one is more of something that in theoretically would engulf you or be bigger than you can see all at once. So there's something about contextualizing you in the experience that's really useful there.
Yeah. So I'm curious how your team has maybe used like VFX and this kind of surround immersive experiences, if you've used that in enhancing like concerts or different like experiences. Maybe you could use the Rivian example if you want, but how have you guys used like visual effects, and maybe tell us something we didn't expect about the way you guys have used some of these tools that you have in your toolbox?
Yeah. So we created some visual effects to help with a local indie show here in Vancouver, the Amplify project. They basically showcase BIPOC artists, and they let them, how do I put it? They platform them for this. So they do concerts every quarter or so, and then they just bring these artists in to perform all night. People come in, people have a good time. It's like they're trying to, because it's against an indie show. It's usually traveling around. They don't have a fixed venue, so when we talked to them, the big thing is like some sort of, like a lot of these shows, if you've been to a concert or a Beyonce concert or something, you'll see they have these crazy light shows and all this stuff going on. That's something people have become a bit more accustomed to. They want, there's always like lighting, there's always things, but people are getting more and more accustomed to that kind of thing. So what we found was they needed a solution that would allow them to have something that's easy enough to set up, that's unmanned, so you don't need somebody, additional person just tuning it the whole show. And finally, you need to do something that was portable, something scalable. So what we end up doing is we sampled a project by Keijiro Takahashi, who's like a Unity developer who's just incredible and has a wonderful repository of just experiments and projects. He just does open source for people to try out and learn, and he pushes Unity to the brink and sees what he can do. And it was a really useful repository because the big thing was at a music show, you want the syncing with the audio is a core aspect. And there's a lot of visualizers on the internet and stuff you can find, but we wanted something that we could personalize to the venue and personalize and again, unmanned. We want something that you could just leave and it's just going to contribute to the show, So we ended up taking one of the samples and customizing it. So basically what it'll do is it'll take in the audio of the room. Mm-hmm. And then every time it hears a loud enough sound, it'll release a burst of visual effects, and that would scale with how intense and consistent the audio is. So as the room got more hyped, as people got more excited, it would get brighter and brighter and brighter and brighter and brighter. And
Wow.
And we're able to adjust like the thresholds, how much is actually inputting, how much it's, so we can, every once in a while, let's say we had a song that was really important to the artist or something, we could just press a button and it'll reduce the threshold. So it could be more intense for that one performance or something,
So we're kind of coming to the end, and I know you have a stop pretty soon. One of the few things I really wanted to know about was how, obviously now cross-platform games is kind of a big thing. Like right now, as far as I know, games increasingly you can play games across an Xbox, across like PC platform, PlayStation platform, and even on mobile sometimes. I don't know if there's one that crosses all the way to mobile, but you need to kind of create games that are capable of operating on these different interfaces. Some of them are maybe even translate to kind of the phone experience as well. So how does that work in terms of creating that adaptability for the experience? It doesn't need to be a game, but
that's a great question. Like I find there are multiple approaches, but a lot of it is so even if you even if you use all the best systems, like I mentioned, Unity's input system, for example, that abstracts all the inputs. Even if you use all of those things and you use all the parameters, it will save you some time. It means that you don't have to do a manual job. It's effectively levels of quality and features you can turn on and off for different platforms. But I find each platform is always going to be a custom solution. No matter what you do, unless you're like, the only time I found where it's never been and even if it's easier, it's still custom. Like I find, so we had a project recently where we're working with a nonprofit, and if I can say at this point, but basically what we're doing is we're helping, we're teaching kids to kind of create interactive experiences. And what we did is the actual delivery is WebGL based. So what that means is we're only making a build strictly built for the web. So once it's uploaded there, it doesn't matter what platform you're coming on. You can play it on if you pull up on phone, it'll work. If you pull it up on your PC, your MacBook, your iPad, it'll work, because it's built from the ground up, it's built to be like agnostic of wherever you're coming from. As long as your thing can handle a browser, it should be able to work. But the thing with that was, even for that solution, I had to basically build two sets of inputs, one for if you're using a keyboard and one for if you're using a mobile touchscreen. So even with that built-in feature of it's going to run on any you still have to make special use cases for. And even that I had to because also think about the difference between mobile and the desktop is you have keyboards, you have all these things you're clicking, you have button inputs. On a touch screen, you have to make buttons on the screen for people to with those inputs on. So it becomes this thing of no matter what you're delivering for, you end up, even if you have systems in place to streamline it, you end up making custom solutions. Even with games, trying to make something that runs on both on Steam, on a PC, on a Switch is going to be, you can't just turn on Switch, just hit a button and it switches to everything. You still have to go, you find out certain shaders or something, certain graphic features don't work on this because there's different processors. Even a big thing with VR development I can attest to is when I'm doing a PC game, I can do, depth of field. I can do, bloom effects. I can do film grain. I can do all these really cool things. When you're on a VR headset, you cannot do any of those things. I mean, you can, but you're going to have basically no content in your thing. So it's like with VR, because VR is a special case in that you have half the budget of most devices because it's as powerful as a mobile device, maybe even a little bit more powerful than a mobile device. But because there's two screens being rendered and they're two different eyes, so because it's stereoscopic, right? So there's two different eyes. So it's rendering two different images. You have to render everything twice. So whatever budget you have, slice it down the middle, right? So it means that there's so many effects you can't do. So if I'm building an experience for a VR platform, I'm building for a PC platform, it means I make the VR version, I take out the fancy volumetric lighting, I take out the heavy duty sounds, the uncompressed wave files, I take out all of that stuff, make it run. I have to figure out how to do certain effects that I have for free in most engines. I have to find a custom solution for the VR version to make sure that the fidelity doesn't look too different. And then when I go to the PC version, I just turn all those settings back up. So it's like, there's kind of like a trickle down effect. If you're starting with PC or something, it's going to be the most powerful. Then you get to like consoles, and then you go lower into like mobile, and then you go into everything else. So it's like you're going to make a custom solution for each one. But I find my workaround is, and this is not a solution for everybody because it's going to depend on per project. But I often, if I'm doing something for a client, then whatever they need is whatever they need. I work around that. I tend to do like exactly what I need and nothing more, because if you try to make everything too perfect and you use a billion features that maybe you don't necessarily need for this project, you end up using your limited resources on stuff that's not core to what your client needs. But if I'm doing maybe an entertainment project, I build like the art direction of it. I would build that I build the limitations into that. If I know that this is a project where I don't have real-time lighting, I'm going to bring an illustrator on to kind of give an art direction that doesn't require fancy shadows or, reflections to look good, right? Because when you know what those limitations are, if you lean into them, then you can turn them into a strength, as opposed to like trying to make something that looks really like it's done like the industry standard and the pipeline. But the problem is when you produce it, because the device can handle it, it just looks kind of weird. I don't know if you saw, I think it was the last Mortal Kombat game, but it looked really good on console. But then when they showed you the Switch version, there are so many features that just didn't work. Like there was no shadows on the face. The certain eye expressions weren't even possible. And it's things like that you lose if you don't build with those limitations in mind. Whereas if you build it for, let's say they built it for Switch, which they can't, because AAA pipelines just don't allow for that kind of thing. But if you built it for the Switch, right, and then you made it look good on the Switch, when you went to like PC or console, it would mean you have a lot more resources to play with. So you can take what you already have and make it look even prettier. Whereas it's hard to go back. You can upscale, you can't really downscale. And with games anyway, it's harder to downscale and make it still look and feel as good as it is. So it's
interesting.
Yeah, that's just cross-platform it's very much you do work for each platform. You do steps to like make it easier, but each thing is a custom setup. So there's no easy way around it in my experience. And maybe somebody's come up with some fancy solution for it, but it's never been straightforward.
Yeah. What I'm going to make my final question though is, and I haven't really asked you so much about your training and some of the preparation you've done in terms of education, and obviously you've gained a lot of experience over the years. So if you could just give us kind of a sense of what kind of training you had to do and preparation you had to do to get to, being the creative director as you are in all these different pipelines, but also for kids maybe who are kind of coming up looking to get into the industry, feel like there's a bit more tools available to them, but maybe make that kind of crystal for us.
Yeah, that's a great kind of question. For me, a lot of it was again, my background was like just art. I was an illustrator for as long as I can remember. Like I was just drawing, although as long as I've been able to talk, I've been drawing and sketching. So I came away from that like approach. I was really into comics, storyboarding, all those things. I used to make films with my brother, blah, blah, it was a whole thing. And then I guess when I got to university, because before I got there, I was already playing around with animation. On an iPad, there's this animation app. I don't know if it's still going. It's called Animation Desk, but my first start with animation. You can just draw frame by frame and learn how to do that stuff. And I came to Emily Carr University here in Canada, and it was interesting for me because I came to study 2D animation, but what happened was the first week I was here, my brother bought a VR headset and he let me try it. And that broke the rest of my undergrad, because it basically meant that I'd seen what kind of like the quote unquote cutting edge of technology and anything was. And it was kind of like, it's hard to go back and draw on paper, after you do that. It's like, it's very hard
Right.
so what happened is it wasn't an immediate straightforward conversion. But what happened is I slowly found myself getting more into the tech art side of things, because that's where I see myself. I wouldn't call myself like a, hard software developer, and I'm not that, but I'm also not firmly, like, I wouldn't consider myself like solely an artist at the same time. A lot of my work these days tends to be like I'm working with artists or in art pipelines to kind of make sure it's all streamlined. I'm trying to figure out how to here's the thing we were trying to do visually or aesthetically or technically. How do I make that actually work? And how do I do both logistically and creatively? How do I balance those two things with what are we technically trying to accomplish at the same time as what are we creatively trying to accomplish? That's where I tend to sit. So I'm always figuring out the in-betweens so it's like, but a lot of that was starting with VR. There's a research lab at Emily Carr that actually saw that I was doing work with VR, because I think at the time it was still very uncommon, right, to be doing any work with VR. And they kind of just brought me up there. My professor brought me up there and just kind of introduced me. And they were like, okay, we see the work you're doing. Seems really interesting. So how about you just come in here and keep experimenting with it, which we'll support you if you want, if you have any questions or anything. But so they just kind of let me do that for years. And I ended up doing a bunch of projects. I had this dream project of making a graphic novel in VR. It was a whole thing for a while. And then like it was kind of my gateway, because I was still coming at it from a purely entertainment standpoint. I loved comics. I loved VR. I wanted to see what was possible design wise, technologically, just wanted to see what it would look like. And through going through that rabbit hole, what happened is, coming at it as somebody who has no experience with the industry, has never run a project like this, you fail very fast. You learn what you don't know. You kind of just practice it until you slowly learn things. And I had a lovely team of people, some of which I still collaborate with today. And we worked on it. We managed to pull it off and actually produce something. It got into VIF. But that whole process was just kind of like, okay, we don't have a programmer. We don't have this. We don't have that. So it meant certain people would have to take on multiple roles on this project and learn things. Like I forced myself to learn Unity, because I was like, I don't have the budget to pay a programmer to do this. So I have to learn enough of this to be able to do it myself. Same with a friend of mine who was an animator, and she picked up the programming because she had some affinity for it. So we both kind of learned. And the more as that happened, it kind of built a confidence of like, okay, I don't know how to do this stuff, but I have a project that requires me to do it, and I want to do that project. So it's almost like once you figure out how to do one thing, you can kind of get enough confidence to feel like you can do the next thing and the next thing and the next thing. So like I taught myself project based, like each project after that, I kept being like, okay, what's something I don't know how to do that I want to learn how to do? And through that process, I taught myself like everything from VR development to 3D modeling to rigging. Like I just kind of taught myself the whole pipeline up until I got to VFX, and I worked at Sony after I graduated. Imagine doing all of that. I'm doing 2D animation. I studied 2D animation, but I'm doing VR in the background. That's my main thing. Yeah. And then Sony reaches out like, hey, do you want to do VFX for Spider-Verse? And I'm like, I don't even know what that is or like what that looks like. But I end up doing that for like a while. And then I learned a ton on the job. And again, as that stuff carries on, you find it all connects in a really interesting way. Being able to do this in VFX means you can do this in games. It means you can do this in film. You can do this in. So the more I just did that, I got into design and UI and all that stuff too. So it's been like this process of one thing just leads to another, where like if you have a project that needs this thing to be done and you don't necessarily have the personnel to do it, I found I would just pick up those skills, and enough of that experience got me into this overlap of like, hey, I know how a lot of these pipelines fit together. I know how to save resources here so we can do this thing here, so it kind of put me, that's why like a lot of time my title is either like technical arts or technical something. It's rarely ever the arts. It's more of the tech, because I'm just in between of like, okay, we want to do this, cool. I know how to save you some horsepower here. You don't actually have to do this. You can save yourself that. It's kind of like, and I find, to answer your question about how people should get their start, I find finding something you personally want to do. Ideally, it has something you don't know how to do in it. Not everything. Wow. Don't make something where there's like 8 steps you don't know how to do. Make something where there's like one big part of your project. For me, it started with, I know how to do comics. I know how to illustrate. I know how to write and make characters and designs. I know how to do the art side of things. I don't know how to make a comic book in VR. What does that look like? How do you get the VR running? How do you get the inputs running so you can move in the story? I don't know how to do any of that stuff. And and things when you learn that process, what I find is there's all these new questions. Like a big thing for the comic thing was, how do, like in a comic book, right? You have the speech bubbles flat on the page. They're one perspective. But in VR, if you can walk around the character, what happens to the comic book, the speech bubble? Like, does it stay in one spot? Because that doesn't feel right. It feels like it needs to. So how do you make the speech bubble follow you, right? And then you do simple things. You make it rotate on its axis, but it doesn't feel right because now the arrow isn't pointing to the character anymore because it's rotating on its axis. So you're like, how do I do that? Then you figure out you need to do an orbit around the character. How do you make that happen? And it's just one thing leads to another, and you start picking up knowledge. And before you know it, it's almost like the moment you know how to do a few more things, the things you can come up with, the ideas you can come up with expands. Because now that I know how to do this dynamic speech bubble thing, there's so many other ideas that come out of that. So it becomes this thing of like, I always recommend to people, like, because like obviously do courses, do all those things. You know, if there's a focus special area that you want to get into, definitely do a course. It's always helpful to do those things. But I always find learning through a project is always better, because if you run through a course and you don't have anywhere for it to go, you're learning these things in a vacuum, so you don't know how they're applied contextually. Whereas if you have a project you have in mind and you're picking up a course to learn how to do the skill, you know where that's going. So you know how to apply it in general, but also within the specific parameters for your project. And it means that you have a wider range of applications. So you learn how the thing works fundamentally instead of just somebody just telling you how to do it and you're just regurgitating it. So that's the way I always approach it, with like trying to get your foot in the door. And I find, again, if you do things and you're vocal about the fact that you did things, like post your stuff on social media, tag people, do all that stuff, people will notice and people will give you work. It's not a merit-based industry. It's, have you done stuff? Who do you know? That's really it at this point. Can you do the work? Great. That's the first step. But can you do the work is not enough. You need to be vocal and clear that you've done it. You have to make sure you've do the festivals, do all the things, because those things kind of give yourself a credibility. It's like, hey, it's not, I didn't just make a cool thing. I made a cool thing and it showed it somewhere else in another country. You know, it's like, it goes a long way rather than you just saying, trust me, I know what I'm doing. It's like, you want to give people as few reasons as possible to go, why you? Like, you know, it's like, give them fewer questions for like, why should I pick you? Why should I talk to you? Like, they give them like, okay, yeah, you've done this, you worked here, or even if you haven't worked anywhere, I can see from your portfolio that you've tried all these things. You've done this thing from start. Yeah. And also the most important part is finish projects. A lot of people start projects, they don't finish them. That's very important. Finishing projects is the hardest part. When you're not excited about it anymore and there's like 50 different little things to do, that's when you need to finish it. Because if you finish it doesn't even matter if it's perfect or not. If you finish it, it tells me, at least if I were hiring or something, I'd be thinking, this was a very difficult project and you managed to pull through and make it work, which means you were willing and able to do it when it got stressful and tiring and boring, but you still finished it. Right. Like, finishing projects is very important. Like, I think a lot of people just don't finish it. They're like, oh, I have a sketch, or I have a wireframe, or I have a tech demo, but they never actually finish the thing. And it's the difference between me going, I can rely on this person, I can't, because a lot of people will tap out of a project the moment it stops being fun, or it starts being like, oh, there's just a mountain of work. Because if you plan a project well enough, you'll hit a point where there's no more surprises. It's just a mountain of work left to do. And that's when most people burn out. That's why they lose. They can't finish. So it's like, that's the part where it's always important. If you're going to start something and you're going to tell people you're doing it, finish it. Make sure you actually finish it. It's very important. Yeah. So sorry. It's a lot. It got very grounded at the end, but yeah.
No, I can, your passion for this field is very palpable. You know, when we first started talking, you seemed like you might be a bit more reserved, and then you just ask you one question and you just peel back all your onion pieces, and it was just like out there.
Yeah.
And this is why I do these things, because I find like with each guest, I kind of learn something new. And this is not something I've ever done before or I have any exposure to. So it's perfect, you know, going into this with you. But I also know you have a stop right now, so I want to respect your time. So I want to say thank you so much for your time today. I really appreciate you going into all those details for us and just teaching us today about what you should do. So for those of you at home, if you're new around here, don't forget to subscribe and ask us anything. Maybe we can get Edward to come in and answer some of your questions. You got to ask him those questions though. Anyways, I'll see you guys on the next one. Take care. Thanks for listening to this episode of the Wolf of Young Street podcast. If you derive value from this podcast, please don't forget to subscribe. I would love to hear from you as well. So please comment your thoughts down below.